In today's lesson, we're going to look at a very important concept in maths, science, and in real life, the distance-time graph. Okay, so we've been asked to describe the journeys that we can see based on these graphs. Now, if you notice, we have distance in the y-axis and we have time along the x-axis. I'm actually going to look at question 2 first. So, as time goes, the distance that this person is from a particular point remains the same. So in fact, this person has stopped. They're not going anywhere. Let's have a look at question 1 now. As time goes by, this person is moving a distance away from a starting point. And can you notice that they are moving at a constant speed, because for each moment of time, that's a moment of time there, they are moving a certain amount of distance, and for the same moment of time, they're moving that same amount of distance. So in fact, the way to describe this journey is that they are moving away at a constant speed. So speed is distance over time. So it's the amount that you travel over a certain time period. Now think about that. Imagine a journey to school or a journey to the shops. You will be traveling a set distance, and you can do it in a different amount of time, and that will determine your speed. So speed is distance divided by time. Okay, let's have a look at question 3. So we've got two things happening here. So up to this moment of time, we're moving at a constant speed, because we are moving away from our starting point. But when we reach this point here, until this point here, the distance from our starting point remains the same. So here we have stopped. Question 4. In this first part, we are stationary, we're not moving, and we are a certain distance away from our starting point. And then in this part here, we are moving towards our starting point because the distance is being reduced. So the distance is going down as time increases. So in this case, and if you notice, it's a diagonal straight line, so we are moving at a constant speed towards our starting point. Okay, this one here, question number 5, the same again. We've got two things going on. So in this first section here, we are moving towards our starting point. That's our starting point there, or our origin, and we are moving towards that at a constant speed, and then we stop, and we are stopped because the distance, this distance here, remains the same over this period of time, so we have stopped. It could be that we're at traffic lights, for example. Okay, here in question number 6, we are moving away. So we're moving this way. We're moving away from our starting point. That's our starting point there, over a certain period of time. It's a straight line, so we move at a constant speed. Then we stop for this period of time, so we're stationary there, and then we continue moving away from our starting point at a constant speed It looks as if it's a slightly different gradient actually than here, so we're moving at a different speed. Hard to tell though. Question number 7. Again, we've got 3 types of motion. In the first part, we are moving away at a diagonal straight line, so it's at a constant speed. So for example, if we went up like that, where our distance was increasing for ever shorter pieces of time, we wouldn't be moving at a constant speed. Our speed would be changing, our speed would be getting greater in this case. But here we have a constant speed in that first section. Then we are stationary. We're stationary at a certain distance. Oops. Oh, go back to that. For example, we might be that we're visiting some friends. So we get to our friends, we've travelled at a constant speed, we spend a certain amount of time at our friends, and then we return home. And we travel at a constant speed again. And question number 8, we've got 3 things going on. We are moving from our origin, from our starting point, it might be our home, to our first destination. It might be that we're going to the shops. We get there, we stay at the shops and might do some shopping, and then we move on from there to our second destination, wherever that might be, and it takes a certain amount of time, and it's therefore at a constant speed. And just to remind you, speed is the distance over time. Okay, in this one, these questions, we're actually going to calculate the speed. So let me just remind you that speed is distance over time. Okay, so in this first question, we have a distance of 3 kilometers, and we achieved that at a constant rate over 2 hours. So our speed is going to be 3 kilometers divided by 2 hours, which is 1.5, and the units of that will be kilometers per hour. So we're traveling at 1.5 kilometers per hour, which is why in the 2 hours we have traveled 3 kilometers. Okay, let's have a look at this one. And so we notice it's a straight line, a diagonal line, so we are traveling at a constant speed, and we're going to work out what that constant speed is. So we have traveled 2 kilometers in 4 hours. So speed is going to be the 2 kilometers divided by the 4 in terms of hours. So that's going to be 0.5 kilometers per hour. And if you have a look at that, you can see that it makes sense. In that 1 hour, we've travelled 0.5 kilometre. In the next hour, we travel another 0.5 kilometre. In the next hour, we travel another 0.5 kilometre. And in the final hour, we travel that final 0.5 kilometre. Okay, so here, same again. We want to find the speed. Just get to write. So if I was doing these questions, the way I would do this is I would write down like this. Speed is distance over time. The distance in this case is 4 kilometers. And the time is 2 hours. And that gives us 2 kilometers per hour. Let's just check if we did do 2 kilometers per hour. Well, in that first hour, we did travel 2 kilometers. In that second hour, we did travel 2 kilometers. And the speed is constant at 2 kilometers per hour. Okay, this is the same thing here. It's just that we are returning back to our destination. So we're starting at 4 kilometers away, and we are returning back to our original destination. That's 0, that's 1, 2, 3, 4, and these are in hours as well. Okay, so the speed is going to be 4 That's 4 kilometers in 2 hours, and that is 2 kilometers per hour. Same with this one here. We've travelled at we've travelled 4 kilometers, so speed is 4 kilometers, and we did that in 4 hours, so we're travelling at 1 kilometer per hour. Let's just see if that's true. Well, in that first hour, did we travel 1 kilometer? Yes, we traveled 1 kilometer. In this second hour, did we travel 1 kilometer? Yes, and we notice that it's constant. A final question. The distance is 2 kilometers and the time is 4 hours. So again, I'll do it properly. Speed is equal to distance over time. The distance is 2 kilometers and the time is 4 hours, and that gives us half a kilometer per hour. And I'm just going to check to see if that's the case. Half a kilometer, that's there, and that took 1 hour. Yes, it did.